Okay, I'd like to talk about organotin compounds. This comes at the end of 2.2.5. It was one of the last sections on preparing organometallics. And a common way, similar to what we saw with boron and silicon, is to do hydrostanylation. That's the equivalent of hydroboration and hydrosilation. Compounds like this are quite readily available. I wouldn't say they're really cheap, but they're cheap enough to be usable, and they're, unlike the boranes, they're actually air stable, water stable, things like that. The problem is they are very toxic. I'll put that in parentheses. Not really cheap, but affordable enough. And so you can add these. Hydrostanylation, it's easier. It's easier than hydrosilation, but a bit slower than hydroboration, but you don't have to worry about things catching fire, which can be a problem with boranes. And so it actually goes via a free radical process, unlike hydroboration, which is a concerted process. So in fact, free radical initiators like AIBN are often used with alkenes. So remember, AIBN is something we learned about in CHEM444 II. That's a common free radical initiator. When you heat it above around 70 degrees, it begins to fall apart and generate free radicals. This reaction is a little tricky if it's a simple alkene, but it goes very smoothly if the Z or the Z can stabilize a radical. And examples of that would be things like a carbonyl group there will help the process, or a C triple bond N, things like that will help. I have run the reaction myself with allyl alcohol, and forget all the conditions now, but it did go fairly smoothly. Okay, with alkynes the reaction is easier. Now I think you just need to warm this. I forget the exact temperature, but I think it's like 40 degrees. This will go. And notice that unlike with hydroboration, which would give the trans isomer, hydrostanylation gives cis isomer. And I think that's a reflection of the free radical mechanism. But you can imagine this is a bulky group here, and in fact if you heat this to about 150, and in fact both of these kinds of vinyl tin compounds are useful for now in fact these vinyl stananes are useful for the palladium catalyzed couplings with tin that are called stellate couplings, which we will cover in 2.3.1, and they're also in the book on page 337 to 9. Related to that kind of palladium chemistry, you'll get a taster of it with this, because you can actually use that same palladium tin type coupling to prepare things like aryl stananes, and I'll give you an example of that here. This compound here is called hexamethyl ditin, and it's not as stable as the equivalent carbon compound would be, where you'd have carbons instead of tins, but it is stable enough to be a commercial compound you buy, and so you can couple it with this sort of chemistry. This compound here, tetrakis triphenylphosphine palladium 0, is a common palladium catalyst we will get to in a minute with some of the organopalladium chemistry. And what you can see is this reaction will tolerate functional groups like nitro that would normally react with things like organolithiums and Grignard reagents. And the other tin goes off like that. The third way is the classic way. Using a tin salt plus Grignard or an organolithium, and that's the typical way that we make organozinc compounds, organocopper compounds, etc. As long as the metal is lower in the activity series than magnesium, this exchange will happen. And finally, fourth way uses an organostanol. That should be two N's there. Organostanol group, like an alkyl group in RLI, because remember, tin is in the same group as carbon, and you can make this kind of tin lithium compound, and it behaves in many ways just like an organolithium. So here's an example of one. If we were to react this aldehyde with a normal organolithium, we would get it adding, at least mainly, across the C double bond O. And this tin compound does the same kind of chemistry. And we get the equivalent of an alcohol, only our alcohol has the tributylstanol group on the end. So those are the main four ways of making organostanines. That's hydrostanylation, and the palladium coupling, hexabutyl ditin. The classic way, just with a Grignard plus a tin halide, and then use of a lithium tin compound.